Alright, if you're watching this video, it means you need a little bit of practice with factoring by grouping. Now, the main idea of factoring by grouping is you're going to be looking at the first two terms in your four-term sequence and the second two terms in your four-term sequence. So I'm going to include that negative with the 25, change that to a positive sign. So, when factoring by grouping, look at your first set of two terms, x cubed minus 3x squared, factor out the greatest common factor. So both of those have an x squared in common. So let's pull out the x squared, and when we factor that x squared out of each of those two terms, we're left behind with an x minus 3. And check yourself, x squared times x is x cubed, and x squared times negative 3 is negative 3x squared. Now look at your second set of terms. So negative 25x plus 75. What do those both have in common? Well, let's go ahead and look at this. Our goal is to get another x minus 3 factor. So we can kind of cheat and play backwards and see if x minus 3 can be factored out of there. If it can, we are in luck. So let's think of negative 25x divided by x, and when we factor that x out, well, we're going to get negative 25. And now let's check and make sure that works. Negative 25 times x is negative 25x. Negative 25 times negative 3 is positive 75. So once again, we are golden. Now, a lot of you in your problems are stopping at this point and saying, all right, I'm done, I factored it. No, you didn't. You factored out an x minus 3 from those two terms, but notice we still have addition between my first term and my second term. This is not factored. Factored means you are dealing with only terms that are being multiplied together. So you are definitely on your way, but you're not done. So now you have to recognize that your first term and your second term, with those big brackets underneath them, both have an x minus 3 in common. So I factor out an x minus 3 from both of those terms, and now what am I left with? Well, I'm left with an x squared and a negative 25. Now, another mistake a lot of you are making is you are squaring x minus 3 because you say, well, there's one there and there's one there, so it's squared, right? No, it is absolutely not squared. Again, you're factoring it out. Those aren't being multiplied. So let's go to a little example here to help explain this point. Think of this, 5 times 3 plus 5 times 2. Well, they both have a 5 in common, so I can factor that 5 out, and what am I left behind with? Well, 3 plus 2. If you guys want to say x minus 3 is squared there, that's the equivalent of saying you had to pull out a 5 squared, but you didn't. You pulled out a 5, not a 25. It's the same idea here when we're dealing with algebraic expressions. But again, check yourself. This makes sense. This works because if I took that term and I distributed in to each of those terms, I'm going to get 5 times 3 plus 5 times 2. You're just using the distributive property. So same idea up here with x minus 3 and x squared minus 25. You could, if you wanted to, take that x minus 3, distribute it in to each of those terms. Well, you'd end up with x minus 3 times x squared and x minus 3 times negative 25. So hopefully you can see that everything we're doing is totally valid. We shouldn't have that squared term. We should end up with this. And now I'm hoping you notice that x squared minus 25 is a difference of squares. So we can write that as x plus 5 times x minus 5. And now f of x is totally factored, and I can look at it and say I have solutions when x is 3, negative 5, and positive 5. And you just factored by grouping. Again, you're looking to do factoring by grouping when you see 4 terms being added or subtracted together.